This is video number 3 for section 8.3. On this one we're talking about sheet metal trades. A four-sided vent connection must be made out of sheet metal. If each side of the vent is like the one pictured, how many total square inches of sheet metal will be used? So we need to identify what we have here. If you look at just this part above here, you will see that we have a trapezoid. And so we can actually just put all of that together on the trapezoid. We just have to figure out the bases, of course, and we know the height. So here's our height. Whoops, let me switch back here. This is going to be our height, 8 inches of the trapezoid. And then we have to figure out our bases. So one of our bases is going to be 8 inches plus these half-inch parts out here, right? This part right here and here. So we have a base that is, we have one trapezoid. And let's call our first base 9 inches. And then our second base is going to be 6 inches. It's going to be 6 inches plus a half an inch on each side. So it's going to be 7 inches. And of course, we already said our height was 8. Okay, so using the formula for an area of a trapezoid, which we've learned in a previous lesson, I have 7 plus 9 divided by 2 times the height. So that's 16 divided by 2, and we've got 8 times 8, which is 64 square inches. And then we have one rectangle there on the bottom. Oops. And so this little tiny rectangle down here is 6 inches times a half inch, right? We've got this little part. It shows it right there. 6 times 1/2. And so we've got 3 square inches. Now here's the thing. It was a four-sided vent, and we're going to make it out of sheet metal. If each side of the vent is like the one pictured, how many total square inches will we have? Okay, so we've got to add these two together, right? So we're going to have 64, I'll say one side of vent will be 64 plus 3. Which is 67 square inches, but there are 4 of them, so all 4 sides will have 4 times 67, and that's 268 square inches. Okay, so you have to read those problems carefully on this one, and we had to split this up. The easiest way to do this was to just do the one trapezoid and the one rectangle, and then we're making 4 sides. All right, so that's that problem. And here's our last one. Okay, so a plot of land in the shape of a right triangle is formed by the intersection of 3 roads. A farmer wishes to purchase the land, which is priced at $6,600 per acre. Calculate the cost of the land given the dimensions shown in the figure. 1 acre is 43,560 square feet. Round to the nearest $100. Okay, so there's a few things that we have to do here. First, we have to find the area of a triangle. It doesn't matter if that's the right triangle. We know the base and the height. All right, here's my base, and here's my height, or vice versa, because it doesn't really matter since we have 2 legs that are perpendicular. So area of our triangle is 1/2 the base times the height of 344, and then we just calculate that. So we've got 46,096 square feet. And then we're going to convert, I think I'll just go ahead and do this, to acres, right? So 1 acre is 43,560 square feet. And so you can see then we're converting from feet to acres, and we're going to divide that. So 4696 by 43,560, and we get about 1.06 acres. And last, find the cost. So we multiply by 6,600, which ends up as 6,996. Now we did round, the number of acres. And then we end up with, if we're going to go to the nearest $100, there's our hundreds, so that ends up at 7,000. Because when we add, right? So we add 1 to the 9, and that ends up making it 10. And so we're at $7,000 for this problem. And that kind of helps too with the rounding. So if you round it a little bit different here, hopefully you still end up at $7,000. Okay, so that's the end of this lesson. Bye, everyone.